Alright guys, this is your 3.4 homework examples. This is this section is something called relative standing, and relative standing is how the values compare to one another, where they are relative to one another, and where they are relative usually to the center, and a lot of times that center value we compare it to as the mean. So we're starting off with z-scores. So the formula for a z-score is the same, basically same thing if it's a population or a sample. So it's x we use to represent a measurement minus the mean. I'm going to use the population mean first, divided by the standard deviation, or if it's a sample we use x minus x bar over s because it's a sample. So we're using sample mean, sample standard deviation in that case, but it's the same thing. You take the measurement, you subtract the mean, divide by the standard deviation. So this is our mean, this is our standard deviation. So we're going to compute what would this z-score be. So for part A, we just take the measurement 89.52, subtract the mean of 90.62, and divide by that standard deviation of 0.77. Alright, so if I want to do this, since that has subtraction in the numerator, I need a parentheses and close that parentheses and then divide by your standard deviation. Alright, so there's our z-score to 2 decimal places, so negative 1.43 if I round it to 2 places. Alright, so that's how you come up with the z-score. Now the other one, 91.82, or part B, same thing. I just take the 91.82, I subtract the mean of 90.62, and then I divide by the standard deviation, 0.77. Alright, one of the things you can do on a calculator, if you're doing the same thing with just different numbers, you press second enter. That brings back the last thing you just did, or the newer calculators you can just press up and highlight the previous problem and hit enter. But then just go in here and change the numbers. Now I want to change that to a 91.82. Alright, and then the rest of it's the same as it was last time. So 1.56 to 2 decimal places. Alright, and then part C, if you notice in part C is a special one. The number they're giving us is the mean. Well, what's going to happen when I plug in the mean for the x and then subtract the mean, because the formula has me subtract the mean? Well, I get 90.62 minus 90.62 over 0.77, which equals 0 over 0.77, which equals 0. So we get a 0 for that z-score. Okay. Now what that means is 0 is going to be our mean. Okay, this value 89.52, that was less than our mean, and we end up with a negative z-score. And then 0.77, oh sorry, 91.82, that was above the mean, so we end up with a positive z-score. So a negative z-score means you're below the mean. All right, positive z-score means you're above the mean. All right, and then a z-score of 0 means that is the mean. Alright, so the closer a measure is to the mean of the data set, the closer its z-score is going to be to 0. The bigger the value is above the mean, the larger its z-score, and the smaller the value below the mean, the larger the negative z-score. Alright, which is relatively better? So because this is a psychology test and this is an economics test, just looking at the numbers themselves is not fair, because we would need to know a little bit more about the data sets. So 82 on a psychology test that has a mean of 85 versus 50 on an econ test that had a mean of 55. So both are a little bit below the mean, okay? But because the standard deviations are different, we might get possibly we will for sure get different z-scores here. So down here on the left side I put a z with a p below it for the z-score for the psychology test, and then the z with the e for the econ test. So an 82 is the score. The mean here was an 85, and the standard deviation was a 10. Alright, over here, the econ, we have a mean of 50, or sorry, a score of 50, a mean of 55, and a standard deviation of 7. Alright, so this has a z-score of -3 over 10, or -3 tenths. This one has a z-score of -5 over 7, or -5 sevenths. And then if you need to, you can convert those to decimals, but you can do it without that if you understand fractions. But if you need decimals, -3 tenths, -5 sevenths. -3 tenths is a negative number that's closer to 0 than -5 sevenths is. So because of that, because -3 tenths is closer than -5 sevenths, that's a better performance, a better relative performance, because it's closer, it's below, both of them are below average, but this one is a negative number that's closer to 0 than the other one is. So in this case, the psychology test score is relatively better. That would be B. Alright, and then something from your second part of your homework in this section is box plots and the 5-number summary. So the 5-number summary is the low value or what we call the minimum value, minimum x, Q1, the first quartile, the median, Q3, the third quartile, and then the max x, the maximum value. So when you're doing this, you can throw it into your calculator. It's easy to do it on your calculator. So you press stat, enter, go into your the top of your list, press clear and enter if you have data in there, and then put your data set in. Alright, I got my data set in there. I can press stat, scroll to the right for the one variable stats, the last 5 values on this. If you scroll down to the bottom, okay, you can't scroll anymore. The last 5 values are your 5-number summary. So the min is 1303, 15.17. Alright, now the way we make a box plot is that we put a box from here to Q1 down to here Q3. It's an ugly Q and a 1. But we make a box plot, or sorry, our box go from Q1 to Q3, and then what we call whiskers go out from the min and the max. Alright, so I've got a number line down here, and I'm going to go from this Q1 1517 to Q3 of 2055. So 1517, roughly about there, to 2055, a little bit more than halfway between 2000 and 2100. So something like that. And then I make these whiskers. The whiskers are going to go out from, I'll make them in like this. Okay, so they're going to go out from Q1 and Q3 all the way to the min and the max. So the min's 1303. So this is going to go from there to about there. And then Q3 all the way up to the 2483 is our max. So there, all the way up to about right there. Alright, so there is the box and the whiskers, and then the last thing we do is put a median. Alright, you can do this before the whiskers, right there at 1906. So there's 1900, 1906 is right about there. And we put a line in there to represent the median, where the median would fall inside our box plot. Okay, you always want to label the median. And if you notice now we've got 1, 2 where the box begins, 3 the median, 4 Q3, and 5 the max. So that's a visual of the 5-number summary with a box around Q1 to Q3. Now, the reason why we use a box here, think about it. This box represents the middle 50% of the data. So the middle 50% of our data is falling between 517 and 2055. So that's why we're drawing attention to that region with that box, because that's the middle 50% of the data. Alright, now I want to show you a calculator can do a box plot. So we have our data in here. Okay, this is the same data set that you're seeing here. Remember, anytime that we want to make a display, we press second Y equals to turn on our stat plot. So we hit enter to go into the stat plot menu, enter again to turn on a stat plot, and then down here just press to the right until you get down to the box plots. This is what's called a modified box plot that shows outliers, and this is a regular box plot. So I hit enter here. Alright, once I'm done, as long as this is where my data is stored, don't mess with the frequency column. Now we press zoom 9 for zoom statistics, and there's our box plot that looks similar to what I have down here at the bottom. Okay. Alright, in this last example, so this is just like an arbitrary definition of an outlier. Okay, we have a numeric way to come up with an outlier. So we add 1.5 of this thing, what we call the interquartile range. Now, what is the interquartile range? The interquartile range is, or what we call IQR, is Q3 minus Q1. It is a range, and just like we compute a range by largest minus smallest, we do the same thing with IQR. So basically, if you think about it, IQR is the width of a box in a box plot. Alright. So what this is saying is we take this width of the box and multiply it by 1.5. So it's basically we're making it 50% bigger than it already is. And we're adding that to the end of Q3 and subtracting it from the end of Q1. And anything that's beyond that is what we consider an outlier. So if these whiskers go too far, if this whisker goes out too far from the right edge of this box, then it could include outliers. Same thing with the lower whisker. If it goes down too far, it may include outliers. So this gives us a way to compute outliers. So first of all, let's find Q3 and Q1 with our calculator. Alright, I have my data in there, stat, right to calculate one variable stats again, and then scroll down to get your 5-number summary. Alright, so there's Q1 and Q3, 19.5 and 3.5. So if I subtract Q1 minus Q3, I'm subtracting 19.5 minus 3.5. Alright, and if you do that subtraction, you get 16. Alright, so this is what I need to multiply by 1.5 and add and subtract that from Q3 and Q1. So 1.5 times 16 is 24. And then if I add and subtract 24 from Q1 and Q3, right, subtract it from Q1, which would be 3.5 minus 24. Alright, that's a negative number. Alright, we don't have any negative data, so I don't have to worry about that. But then if I take the upper number, 19.5, and I add 24, 23.5, that would be 43.5. Alright, so anything above 43.5 would be considered an outlier. So 52 is an outlier. Okay, now there's, actually I did this out of order. There's the answer to part B. The interquartile range is 16. The 5-number summary, I computed that on our calculator. There was it. Alright, 1 all the way up to 52, and then there's the Q1, the median, Q3. There's the 5-number summary. Alright, and then there's the outlier. Now, if you go in and do a modified box plot of this, So hit enter, and instead of selecting the one we selected last time, if we go to the one right beside it and select modify box plot and hit enter, and now hit zoom 9, notice that it put a dot right here, and if I press trace, what it now does is it extends the whisker to the largest value, 32, that's not an outlier, and then it marks the outlier with a dot or a star or something, whatever we pick to use. So that's another way that you can find your outliers without having to really compute that 1.5 IQR stuff. If you just put your data set in and modify your box plot, it'll identify an outlier for you.